Well, this time let's see a completely new concept, the concept of basis. What is a basis? Well, you already seen the concept of a vector space. But what is a basis? Well, a basis is a special subset of a vector space. And call that subset of vectors of a vector space by v1 through vn. And by the way, is the dimension of the space. If you are in three-dimensional space, a basis would have three vectors. If we are on two-dimensional space, our basis has just two vectors. So let's call that vector space V. And so the set V1 through Vn is a basis of V. But I told you, it is a special subset. What does it mean, special? Special means it has two properties, 1 and 2. The first property is that the span of that subset is the vector space V. This is quite easy to understand, so all the possible linear combinations return us to V. This is the first property. The second property is that those n vectors are linear independent. Two properties, very easy to understand, but to make this more clear, now let's see an example. Let's imagine we live in R2, a two-dimensional space. R2, the plane that you see on the screen. And from all the vectors on the screen, I'm going to choose two, called Ex and Ey, as shown here. Let's check these properties. Thus, it is a subset, of course, with just two vectors, but let's see. Let's see if they span the entire thing. Intuitively, they do. So there is every single vector on the screen can be written as some appropriate linear combination of Ex and Ey. So I can write that the span of Ex and Ey is R squared. Moreover, are they linearly independent? Well, they point in different directions, and as a result, I cannot create one from the other. So they are indeed independent. Therefore, this set, Ex, Ey, is in fact a basis of R squared. Notice that it is not the only basis for R squared. I can also choose Ex and Ey prime, that you find here in blue. Those span as well the entire plane here. Additionally, they are linearly independent, so the span of this set also returns R squared. Moreover, any two pair of independent vectors from R squared is a basis for R squared. So any two work. Now, what can I do? If I have this basis, what can I do with that? Well, what I can do is written downstairs. So I can write any vector with respect to the chosen basis. For example, some vector u can be written as Cx, a real number, times Ex plus Cy times Ey, where Cx and Cy are the coordinates of the vector u with respect to that basis. Well, but if I consider a second basis, Ex prime and Ey prime in blue, now I can write u with respect to this basis by some appropriate linear combination. Well, this is very intuitive because u lives in this plane. And within this plane, I chose these two important reference, these two important vectors. And with respect to those, I can now write every vector on the R squared with respect as some linear of combination of these chosen two. With respect to this chosen two, I get these coefficients here, called the components of u with respect to this basis. It might be useful, and to make an analogy. Let's assume that I'm trying to describe the personality of somebody as being, and my reference personalities are happy personality, like this, and the confused personality. So this is my two reference, my choice. And now I have somebody, for example, and with respect to this basis, I'm going to describe this person. And I'm going to say, for example, well, I need to give a factor, for example, let's take 70% plus, I don't know, 10%. It's an example. So, but the key idea here is that the person, with respect to this basis, so the personality with respect to this basis, is characterized by 70% and 10%. But the person is still the same. If I choose a different reference, so different personalities, I have different numbers. The same thing happened here. The u vector, which lives in R squared, is still a vector. It's in there. But depending upon the basis that I choose, ex, vy, or ex prime, ey prime, this vector, describing this vector with respect to these different bases, they look different, meaning the components will look different. These numbers